Question 2 says find the quadratic polynomial each with the given numbers as the sum and product of its zeros respectively. Okay, so in this question we are given, for example, this is the sum and this is the product of the zeros. So we have done a very similar question in example 4. If you haven't watched that video, you can watch that. But regardless, we are going to do this once again. Okay, let us start with the first part. Let the quadratic polynomial b, let us assume it to be ax square plus bx plus c, where a is not equal to 0, and let us assume its zeros to be alpha and beta. So here we are given the sum is 1 by 4. So sum of the zeros is 1 by 4 and product of the zeros is minus 1. Now if you note from here, we have sum of the zeros as minus b by a and product of the zeros as c by a. So in the denominator we are having a for both alpha plus beta and alpha beta. So what are we going to do in these questions is when we are given alpha plus beta and alpha beta, we are going to make the denominator same for both the fractions. So I can write alpha beta equals to minus 1 as minus of 4 by 4. Why? Because I have to make the denominator in alpha plus beta and alpha beta to be same. Okay. So now alpha plus beta I know is minus b by a and alpha beta is c by a. Now in both the cases, if you see, a is equal to 4, right? So I can say a is equal to 4. Now minus b is equal to 1, so I can say b equals to minus 1 and c equals to minus 4. So one of the quadratic polynomial that fits the given conditions is, we assume the quadratic polynomial to be ax square plus bx plus c. Now let us put the values of a, b and c in this polynomial. So we get 4x square minus x minus 4. And any quadratic polynomial that would fit the given conditions would be of the form k into 4x square minus x minus 4, where k is a real number. Now let us come to the second part. Okay, again we will assume the quadratic polynomial to be ax square plus bx plus c, where a is not equal to 0 and the zeros are alpha and beta. So we are given the sum. Sum of the zeros is root 2 and the product of the zeros is 1 by 3. So now we have understood from the first part that we have to equate the denominator in both of these terms. So over here, if I multiply and divide it by 3, what do we get? 3 root 2 upon 3. So in both the cases, here and here, the denominator is equal. Now we know that alpha plus beta is minus of b by a, and we know that alpha beta is equals to c by a. So I can say a is equal to 3 in both the cases and minus b equals to 3 root 2. So b equals to minus 3 root 2. And similarly over here if we see c equals to 1. So the quadratic polynomial that fits the given conditions can be written as, if we put the values over here, we get 3x square minus 3 root 2x plus 1. And any other quadratic polynomial that would fit the given condition would be of the form k into 3x square minus 3 root 2x plus 1, where k is real. Now let's come to the third part. Okay, again similarly we will assume the quadratic polynomial to be ax square plus bx plus c, where a is not equal to 0, and let alpha and beta be the zeros of this polynomial. Alright, so we are given the sum of the zeros is equal to 0 and the product of the zeros is equals to root 5. So I can write this as 0 by 1. I can write this as root 5 by 1. Now I know alpha plus beta is minus b by a, and alpha beta is equals to c by a. Right? In both the cases, a is equals to 1. So I can say a equals to 1, minus b equal to 0. So b equal to 0 and c equals to root 5. So if we put these values over here, we can say that x square plus 0 into x plus root 5 equals to x square plus root 5 is the quadratic polynomial which fits the given condition that the sum and the product of the roots is 0 and root 5, and any other quadratic polynomial that would fit the given condition would be of the form k into x square plus root 5 where k is real. Now let's come to the fourth part. Okay, again we will similarly assume the quadratic polynomial to be ax square plus bx plus c, where a is not equal to 0, and let alpha and beta be the zeros of this polynomial. So now we are given that the sum is 1, sum of the zeros is 1, and the product of the zeros is also 1. Alright, now I can write this as 1 by 1 and I can write this as 1 by 1. I know that alpha plus beta is minus of b by a, and alpha beta equals to c by a. So from here we can say that a equals to 1. Now minus b equals to 1. So I can say b equals to minus 1 and c equals to 1. So if you put these values over here, we can say that x square minus x plus 1 is the quadratic polynomial which fits the given conditions, and any other quadratic polynomial that would fit the conditions would be of the form k into x square minus x plus 1 where k is real. Now coming to the fifth part of the question. Again we will assume the quadratic polynomial to be ax square plus bx plus c, where a is not equal to 0, and let alpha and beta be the zeros of this polynomial. So we are given that the sum of the zeros is minus 1 by 4 and the product of the zeros is 1 by 4. Now this is equals to minus b by a, this is equal to c by a. Now here you can note that a is equals to 4 in both the cases. So you need not multiply or divide the fractions by anything. So here I can say a equals to 4. Now minus b equals to minus 1. So I can say b equals to 1 and c equals to 1. Alright. So if you put the values over here, I can say that 4x square plus x plus 1 is the quadratic polynomial that fits the given conditions, and any other quadratic polynomial that would fit the given condition would be of the form k into 4x square plus x plus 1 where k is real. Now let's come to the last part of the question. Again we will assume the quadratic polynomial to be ax square plus bx plus c where a is not equal to 0, and we will assume that alpha and beta are the zeros of this polynomial, right? So we are given what is alpha plus beta, it is equals to 4, and what is alpha beta, it is equals to 1. So I can write this as 4 by 1 and I can write this as 1 by 1. Alright. Now I know that alpha plus beta equals to minus b by a and alpha beta equals to c by a from here. Okay. So from these two, what I can say is a equals to 1, right, in both the cases, and minus b equals to 4, right? So b equals to minus 4, and what is c? C equals to 1. So if we put these values over here, what I can say is x square minus 4x plus 1 is the quadratic polynomial which fits the given condition, and any other quadratic polynomial that would fit the given condition would be of the form k into x square minus 4x plus 1, where k is a real number, right? So if you have any queries, leave them down in the comment section below and subscribe to the channel and share the video with your friends.